Welcome to Exam Essentials. Today we will be discussing the most recent Edexcel A-Level Pure Mathematics-4 question paper. This paper is from May 2025. So this is question number 1. We can see that in question number 1 we have a curve C that has an equation 2y square minus 6xy equals to 7 e to the power of 2x minus 1 plus 13. We can see that the point P with x coordinate half lies on our curve C. In part A, we have to find two possible y coordinates of P. We know that point P lies on our curve C. What this means is that the coordinates of P satisfies our equation. This means that we can substitute the value of the x coordinate, which is half, in our equation, and when we find out the value of y from this, we will essentially be finding out the y coordinates of P. So let us solve this. In part A, we know that at uh, at P, x is equal to half. Substituting this value of half in our expression for our curve C, in our equation for curve C, will give us the y coordinates of P. So let me write out our equation for our curve. 2y square minus 6xy, 2y square minus 6xy is equal to 7 e to the power of 2x minus 1 plus 13. This is our expression. Now we are going to substitute x equals to half in our expression. So we will write 2y square minus 6 into half into y equals to 7 e to the power of 2 into half minus 1 plus 13. Now we are going to simplify this expression. 2y square minus 6 into half would be 3. So 3y is equal to 7 e to the power of 2 into half into minus 1. This will give us 2 into half will give us 1. So 1 minus 1 is equal to 0 and plus 13. Again, we can simplify further. We can see that on our left hand side we have 7 into e to the power of 0. We know that e to the power of 0 is equal to 1. So we will have 7 plus 13 on our right side. Bringing all the terms to the left, we get 2y square minus 3y minus 20. We see here that we have a quadratic equation. Now to solve for the values of the y coordinate, we need to solve this quadratic equation. There are many ways of solving a quadratic equation. We can use the middle term method to solve this. Here we can see that when we multiply this term, this coefficient and this coefficient, we get 40. And we can write out 40 as 8 into 5. We can also see that plus 8 and minus 5 is equal to 3. Realizing this, we gives us the terms that we need to use in our middle term. So using this information, I can write 2y square minus 8y plus 5 minus 20 is equal to 0, minus 5x. Minus 20 is equal to 0. So this will be our middle term. the second step for our middle term. Now we can see that from the first two terms we have 2y as common in both of them. So separating 2y out will give us y minus 4 inside our brackets, and then from the last two terms we can take 5 outside our bracket, and this will give us y minus 4 inside our bracket. So now I can write that 2y plus 5 into y minus 4 is equal to 0, and 2y plus 5 and y minus 4 are the two factors for this quadratic equation. From this I can now write that 2y plus 5 is equal to 0, or y minus 4 is equal to 0. So y is equal to minus 5 by 2 and y is equal to 4. These are the two possible y coordinates of P. We can see that we have solved this function by substituting the value of x, which is half. The value of x we substituted in our function is the x coordinate of P. That's why the y coordinate that we obtained from here are the possible y coordinates of our point P, and that's why this is our answer. So we can write the y coordinates, the possible y coordinates can be either minus 5 by 2 or 4. This is our answer for part A. For part B, we see that it is given that our point P lies above the x-axis. We know that if a point lies above the x-axis, its y-coordinate has to be greater than 0. If we try to see it from a graph, this is our y-axis and this is our x-axis. Now, if there is a point that is above the x-axis, that lies above the x-axis, it must have a y-coordinate that is positive. From our previous part, we can see that there was two possible values for the y coordinate of P. One was minus 5 by 2, another was 4. So we can see from this that the only possible y coordinate of P has to be y equals to 4. Y equals to minus 5 by 2 cannot be the possible y coordinate of P because it is negative. So we can write y equals to 4 is the y coordinate of P. So we can now write that the coordinates of P is half and 4. Now we further read that we have to find an equation for the tangent to our curve C at our point P, and we have to give our answer in the form ax plus by plus c, where a, b and c are all integers. So in order to find an equation for the tangent to our curve C, we need to find the gradient of that tangent line, and we also have to find a point that lies on our tangent line. For the point that lies on our tangent line, we can use our point P. As the tangent formed is at point P, we can use the point P as a point on the line. As for the gradient of the tangent, we have to calculate the gradient of the curve at point P, and that will be the gradient of the tangent. So at first we have to calculate the gradient of the curve at point P. We know that tangent to a point at a curve is equal to the gradient of that point on the graph. That's why we first have to calculate the dy by dx of our expression, and then we have to find the gradient at p from our expression for dy by dx. So let us start solving this. We know that y is equal to 2y square minus 6xy. I'm sorry. We know that y square is equal to 2y square minus 6xy equals to 7 e to the power of 2x minus 1 plus 13. Now, in order to differentiate this function, we see that we cannot isolate the y terms from this expression. It is just not possible to separate out the y terms and make y the subject of this formula. That's why we have to differentiate this function implicitly. To do this, we will assume that each variable y is a function of x. And when we make this assumption, we can differentiate this function implicitly. So we can write differentiating with respect to x or expressions. So what this will do is this will differentiate every single term of our equation. So d dx of 2y square minus d dx of 6xy equals to d dx of 7 e to the power of 2x minus 1 plus d dx of 13. Now if we simplify from this, we can write that d dx of 2y square will be equal to 2 into 2 into y. The reason why we could differentiate like this is because we are assuming that y is a function of x. So if y is a function of x, a function of x to the power of 2 is equal to 2y. And as we have assumed that y is a function of x, we need to differentiate. We need to differentiate our function y, and we have to multiply it with our answer. Next, we have to find the ddx for 6xy. We know that we have assumed y as a function of x. So what we can see from here, we have two functions. One is 6x and another is y that are multiplied together. And we cannot simplify this. That's why we have to use the product rule to differentiate this. Using the product rule will give us using the product rule, we will take 6x and we will differentiate y, which will give us 1 into dy by dx. Then we will add y into the differentiation of 6x, which will be equal to 6 into 1. Next, we have the right side of our equation. In the right side, we have ddx of 7 e to the power of 2x minus 1. Now, the differentiation for this would be 7 e to the power of 2x minus 1 into the differentiation of 2x minus 1 In this function, in this expression, we have assumed that 7 e to the power of 2x minus 1 is a function for is the function ex. So we have differentiated it with that assumption, and now we have to differentiate whatever we thought of as the function. So we need to differentiate 2x minus 1, and we have to multiply that with our expression. This gives us 2. Then we will have the ddx of 13. 13 is a constant term, that's why the differentiation for 13 would be 0. Simplifying further, we get 4y into dy by dx minus 6x dy by dx minus 6y is equal to 14, because 7 into 2 would be 14. 14 e to the power of 2x minus 1. Now we will keep all the term with the dy by dx term on our left, and we'll move all the other terms to the right. So 14 e to the power of 2x minus 1 plus 6y on the right. Now we can take dy by dx common from this both terms, from these two terms. So we get 4y minus 6x equals to 14 e to the power of 2x minus 1 plus 6y. From here we can see that dy by dx is equal to 14 e to the power of 2x minus 1 plus 6y divided by 4y minus 6x. And this is our expression for dy by dx. This expression gives us the gradient of every single point on our curve. Now we will use this expression together with the coordinates of P to find the gradient of our curve at point P. So now we can say that at P, x is equal to half and y is equal to 4. Substituting these values into dy by dx would give us 14 e to the power of 2x minus 1. So we know 2 into half minus 1 plus 6y. So 6 into 4 divided by 4y minus 6x. The denominator was 4y minus 6x. So 4 into 4 minus 6x minus 6 into half. So we will simplify this. We get 14 into the power of 0 plus 6 fours are 24 divided by 4 fours are 16 minus 6 into half is 3. So we know that e to the power of 0 is 1. So 14 plus 24 will give us 38 divided by 13. And this is our gradient at point P. Now for the gradient of tangent, we know that it is a property of the tangent that it is parallel to the point that it is situated on the curve. So we know that the gradient of the tangent is equal to the gradient of the curve at that point. So the gradient of the tangent at point P will be equal to the gradient of the curve at point P. So the gradient of the tangent is equal to 38 by 13. Same as the gradient of the curve. Now we can write down the equation of the tangent. We know that the general formula for finding out an equation for a line is y minus y1 equals to m x minus x1. We know that m, or the gradient, is equal to 38 by 13. We also know that a point through which our tangent passes through is point P, which is half and 4. So we can use these values to calculate the value of our tangent line. Y minus y1, y1 is equal to 4, and m is equal to 38 divided by 13, and then we have x minus x1, which is x minus half. Now we have y equals to 38 by 13. I'm sorry, we have y minus 4 equals to 38 by 13, x minus 38 by 13 into 2. Multiplying both sides by 13 into 2 gives us 26y minus 104 is equal to 38x minus 38. The value here will be 76 because we are multiplying it by 13 into 2. Now bringing all the terms to the left would give us minus 76x plus 26y minus 104 plus 38 is equal to 0. So this gives us minus 76x plus 26y minus 66 equals to 0, or from this we get 76x minus 26y plus 66. We can divide by 2. Divide by 2 for every single term, and we will get 38x minus 13y plus 33 as our answer. And this will be our equation for the tangent. And this concludes our question number B. This was our question number 1. In part A, we had to calculate the y coordinates, the possible coordinates for y. So this is our answer for part B. So this is our answer. So this is our answer for part B. We can now move to our question number 2, because this concludes our question number 1. So this is our question number 2. We can see that in question number 2 we have a spherical ball of ice with radius r centimeter is melting. So we have a ball that is spherical and it is made of ice, that's why it's melting. The sphere has a radius of r. Now the volume of the ball of ice v centimeter cube is decreasing at a constant rate, k centimeter cube per second, where k is constant. Now it's given that v is equal to 4 by 3 pi r cube. So we can see that a relationship between v and r is already given, and we have to show that the rate of decrease of the radius is inversely proportional to the square of the radius itself. So at first we will list all the information given in the question. We can see that it is given that the volume of the ice is decreasing at a constant rate. So the decrease in volume of the ball per unit time is given. So we know that dv by dt is given. We know that dv by dt is constant. From the question we know that. And it is decreasing at a rate k centimeter cube per second. So we can write dv by dt is equal to plus minus k centimeter cube per second. The reason why it is plus and minus is because we need the dv by dt to be negative. We know that the volume is decreasing per unit time. It is not increasing, it is decreasing per unit time. What this means is that dv by dt would be negative. But uh, what we are told in the question that is that the constant rate is k centimeter cube per second. As the constant rate is k centimeter cube per second, we do not know whether or not our value of k is positive or negative. We need to make sure that our value of dv by dt is negative. That's why we are giving a plus and minus sign here, because if the value of k is already negative, we will use the plus sign, and if the value of k is positive, we will use the negative sign before that. And this will give us a negative dv by dt. So now we can see in the question that we have to show that the rate of decrease of the radius of the ball is proportional to the square of the radius. So we have to find the rate of decrease of the radius of the ball in order to show this relationship. So we can say that dr by dt. We have to find out the value of dr by dt. We can say that we can relate all the rates. We can see that this is given, and we also know an expression of v and r. Given these two things, we can relate the rates of dv by dt and dv by dr in order to find dr by dt. So I can write dr by dt is equal to dr by dv into dv by dt. Notice from here that cancelling out dv and dt gives us dr by dt. So the left hand side and the right hand side are equivalent. Now the reason for writing this like this is because we can find out the dr by dv term here, and we also know the dv by dt term. So we are writing this is the reason we are writing this is because we know the information for this too. So we can use those information to calculate a value or an expression for dr by dt. So in order to find the value of dr by dv, we have to use this expression. We can see that there is only one equation that links our volume and our radius. So from that equation I can find dv by dr. Again we are finding dv by dr and not dr by dv directly, is because the v is the subject of this formula. So it is easier to calculate dv by dr instead of dr by dv. So if we calculate dv by dr in this expression, we get 4 by 3 pi into 3 r square. So simplifying this, we can see that 4 by 3 and into 3 will give us 4 pi r square, and this is equal to dv by dr. But we have to find out dr by dv. To find out dr by dv, we just have to inverse our expression for dv by dr, which will give us 1 by 4 pi r square. We can now substitute the relevant expressions in our relating rate equation. So dr by dv is equal to 1 by 4 pi r square into dv by dt, which we know is equal to plus minus k. So ultimately this will give us plus minus k 4 pi r square. From this we can now see that dr by dt is equal to plus minus k divided by 4 pi r square. I can write out the constant terms together. These terms are constant in our expression here. Into I can write down 1 by r square, and on the left side we have dr by dt. From this we can clearly see that dr by dt is proportional to 1 by r square, or in other words, from here we can see that dr by dt is inversely proportional to its radius squared, and we have shown this. So this was our question number 2. We can now move on to our question number 3. So this is our question number 3. We can see that in this question we have a differential equation y into cos square 2x into dy by dx equals to 3 sine 2x. And in this question we have to solve this differential equation, and we have to write our answer in the form y square equals to gx, or we have to write it in the form y square equals to a function of x. So we can start solving this. In order to find a solution to our differential equation, I will first write down the expression in the question. So y cos square 2x dy by dx is equal to 3 sine 2x, and this is our expression in the question. Now to solve a differential equation, we know that we have to separate out the dy and the dx terms. So we need to separate out the dy and the dx terms. The dy terms stays in the left side, and the dx term will move on to the right side. We also know that we have to keep the y variables on the left and all the x variables on the right. So doing this we get y on the left, and we move cos square x on the right side. So this will give us 3 sine 2x divided by cos square 2x. Ultimately we now have to bring out the integration term here. Now this expression that we got here, solving this expression will give us the solution to our differential equation. So let me solve this. Let me solve the left side first. So solving the left side will give us by 2 we can see from here that in order to integrate y in terms of dy, we have to increase the power of y by 1. So here we have the power of y is 1. So we will increase the power of y by 1. This will give us 2, and then we will divide by the new power. So y square divided by 2 is our integration for the left side. Now on the right, we can see that we have to simplify this expression before continuing with our integration, because this cannot be integrated. A function, an expression in this form cannot be integrated. That's why we have to first simplify this. We can bring out 3 before the integral sign, and then we can write our expression as sine 2x divided by cos 2x into cos 2x dx. We can further simplify this as sin 2x divided by cos 2x into 1 by cos 2x dx. Further simplifying this, we get that sin 2x divided by cos 2x will be equal to tan 2x. We already know this from our identity. We know that sin x divided by cos x is equivalent to tan x. From this identity, we have written that sin 2x divided by cos 2x is equal to tan 2x. Now we also know that from our definition of sec x, cos x and cot x, we know that 1 by cos x is sec x. So 1 by cos 2x will be equal to sec 2x dx. Now this is our simplified expression that we can integrate now. On the left side, it is still y square divided by 2 plus c. The c is from the constant of c is the constant of integration. Now we can see that now we know that the integration of tan 2x and sec 2x will be equal to sec 2x. From our definitions, we know that the integration of tan x and sec x is equal to sec x and plus c. We know this from our definition. Here we see that we are given to integrate tan 2x and sec 2x. What this means is that we have to apply the chain rule here. So in order to integrate this, we will assume that our 2x is x and then we'll integrate it. So this will give us sec 2x. But as we have assumed that our 2x is equivalent to x, we need to differentiate 2x and divide our expression with it. And then we have a constant of integration. Let's say this is k. We are using a different constant of integration this time because we do not need to equate the two constants. We have already used c for one of the constants, so we are now using k for the other one. Now simplifying this, we get 3 by 2 sec square to x. We know that the we know that ddx of 2x will be equal to 2. That's why we get 3 by 2 sec 2x here. From this we can see that y square by 2 equals to 3 by 2 sec 2x plus k minus c. We can write this k minus c as a new constant, just to simplify things a bit. So this gives us y square divided by 2 equals to 3 by 2 sec 2x plus a. At this stage, we can see that we are almost there. We can almost see our answer. But the problem is that in our expression, in our final expression, we have an unknown, that is a. So we need to find out the value of this unknown before we can declare this expression as our answer. So from the question, we can see that 2 points for x and y are given. At x equals to pi by 6, y equals to 4. So we can use these values and we can input these values into our expression to get a value of y, to get a value of a. I'm sorry. So I can write at x equals to pi by 6, or our y is equal to 4. So I can write 4 square by 2 is equal to 3 by 2 sec 2 into pi by 6 plus a. So this will give us 16 by 2 equals to 3 by 2. We know that sec we know that the sec pi by 3 will be equal to 2. Sec pi by 3 is equivalent to 1 by cos pi by 3. Cos pi by 3 is equal to half. So 1 divided by half would be equal to 2. So 16 by 2 into 2 plus a. So this can be written as 8 equals to 5 plus a. So a, or our constant, is equal to 8 minus 5, which is 3. Now we can use this value to write our final equation, and that would be our answer. So y square by 2 is equal to 3 by 2 sec 2x plus 5. So multiplying both sides by 2, we will get y square equals to 3 sec 2x plus 10. And this is our answer for question number 3. We've written our solution in the form y square equals to a function of x. So this concludes our question number 3. We can now move on to our next question. Question number 4. So here is our question number 4. We can see that we are given a function fx is equal to 5 plus 17x minus 10x square divided by x into 1 minus x into 2x plus 1. Now for part A, we have to write fx in the form a by x plus b by 1 minus x plus c by 2x plus 1. We can see that we have to convert. We have to write our function in terms of partial fractions. Our function fx is a combined fraction, and we have to write out our function fx as partial fractions. So to do this, we will first equate our function with its partial fraction form. So 5 plus 17x minus 10x square. So 5 plus 17x minus 10x square divided by x into 1 minus x into 2x plus 1 will be equal to its partial fraction form. We will equate it with its partial fraction form. So a plus a by x plus b by 1 minus x plus c by 2x plus 1. This is its partial fraction form. What we can now do is we can multiply both sides by the denominator of our original function. We have to multiply both sides by our denominator. Doing that will give us 5 plus 17x minus 10x square on the left side. But on the right side, we can see that when we multiply a by x with our denominator, we will see that our x gets cancelled out, and we get a into 1 minus x and 2x plus 1. We will repeat this process for b and for c. So b by 1 by x, when multiplied by x into 1 minus x into 2x plus 1, we will see that 1 minus x will cancel out, and this will give us b into x into 2x plus 1. For c, if we multiply this fraction with our denominator, x into 1 minus x into 2x plus 1, we can see that these two cancel out, and we can see that ultimately we can write cx and 1 minus x. So this is our expression when we multiply both sides by our denominator of our original function. Now we can use this to find the value of a, b, and c finding the value of a, b, and c will give us the values of the partial fractions. Now to find the value of a, b, and c, we will choose specific values of x that makes the that makes the value of other two, that makes the value of one single variable stand out, and other two variables will disappear. Let's say, for example, in our expression, let's say we substitute the value of x equals to 1. If we substitute this value, we can see that when we substitute x into our expression, this term, the 1 minus x terms becomes 1 minus 1, which is equal to 0. So these terms become 0. What this does is this makes the whole expression 0. So this expression vanishes. In this case also we can see that in the case of c also we can see that putting 1 in our expression of 1 minus x gives us 0. What this means is that when c and x is multiplied to 0, this whole expression will become 0. So what we see is that two expressions with our unknowns a and c, they disappear, they become 0. So we can see that the only unknown is b in the whole expression. So we can calculate the value of v from that. So let us do this. So at x equals to 1, I will substitute x in our expression, into our full expression. So 5 plus 17 into 1 minus 10 into 1 square is equal to a into 1 minus 1 into 2x plus 2 1 plus 1 plus b into 1 into 2x, so 2 1 plus 1 plus c into 1 into 1 minus 1. From here, if we simplify, we get 5 plus 17 minus 10 equals to, again, our this term becomes 0. That's why multiplying a into 0 into this term will give us 0 for the whole expression. So we can write 0 plus b into 1 into 3 plus, again, this term will become 0. So multiplying c with 1 with 0 will give us 0 for the whole expression. We can see from here the only unknown in this whole expression is b. That's why we can calculate the value of v very easily from this function. We just have to make b the subject of this expression, of this equation. So if we simplify now, we get 12 is equal to 3b, or b is equal to 12 by 3, so b is equal to 4. Now I will choose another value very strategically in order to eliminate two of the unknowns, so that again in our expression there is only one unknown. So in order to do this, I will choose x equals to 0. We can see from here x is present in both these terms. So substituting x equal to 0 into both of these terms will make this both terms 0. So ultimately our term a will be isolated, and we can find the value of a from our expression. So we can write, so we can now substitute it at x equals to 0. Our expression will be equal to 5 plus 17 into 0, 17 into 0 minus 10 into 0 square equals to, again, a into 1 minus 0, 2 into 0 plus 1 plus b into 0 into 2 into 0 plus 1 plus c into 0 into 1 minus 0. If we simplify this, we can see that the left side is only equal to 5, and for the right side we see that a into 1 into 1 plus 0 and plus 0. So 5 equals to a, or a equals to 5. So we now have the value of a, and we now have the value of b. We can use these values of a and b, and we can substitute a and b in our expression, and then we can choose the value of x, and then what we can do is we can isolate c to find our value of c. So I can write, let's say, putting a equals to 5 and b equals to 4 and x equals to, and okay, first of all I will write out the new expression with our known values. So our new expression would be 5 plus 17x minus 10x square is equal to 5 into x minus 1, sorry, into 5 into 2x minus 1, 1 minus x and 2x plus 1. So 5 into 1 minus x and into 2x plus 1, plus we know b is 4, so b into x into 2x plus 1 plus c. We do not know the value of c, so it will be c into x into 1 minus x. So this is our new updated equation. We can see that there are only two unknowns in this whole expression, the value of x and the value of c. So if we choose an arbitrary value for x, we know x is a variable and c is a constant, so we can choose an arbitrary value for x. Let's say x equals to 2, and if we substitute this value of x into our expression, we can find the value of the constant c. As x is a variable, we can choose any values of x to put in our expression. So 5 plus 17 into 2 minus 10 into 2 square will give us 5 into 1 minus 2 into 2 into 2 plus 1 plus 4 into 2 and 2 into 2 plus 1 plus c into 2 and 1 minus 2. So now simplifying this will give us 5 plus 17 into 2, which is 34, minus 10 into 2 square, 40. Again this will give us 5 into 1 minus 2, which is minus 1, into 2 into 2 is 4 plus 1, which is 5, plus 4 into 2, which is 8, into 2 into 2 plus 1, which is 5, and c into 2, I will write it out as an expression. So 2c into minus 1. So 5 plus 34 minus 40 is minus 1. So minus 25 plus it was a 40. 8 5s are 40. And we have here minus 2c. From this we can see that c is the only unknown in this equation. So we can make c the subject of the formula and we will find the value of c. So c is equal to c is equal to 8. As we now know the value of a, b, and c, we can write out the expression for our partial fraction. So the final expression for our final partial fraction is that we know that the partial fraction was equal to a divided by x and b divided by 1 minus x and c divided by 2x plus 1. We knew from the question that this is our expression for partial fraction. Now we will put the value of a, b, and c into our expression. We know that a is equal to 5, b is equal to 4, and c is equal to 8. So we will input our values here, 5 by x plus 4 by 1 minus x plus 8 by 2x plus 1. This is our final expression for the partial fractions. So we had a combined fraction in our function, and we are now writing it as a partial fraction. Next, in part B, we have to use our part A. We can see that a conjunction is used, which is hence. In part B, it is said that hence use algebraic integration to find the exact value of integration of fx with the limits 4 and 2. So, and we have to give our answer in this particular form. Now, as hence is used, we have to use the part A to calculate our algebraic integration. So for part B, I can write, we have to calculate the integration of fx. We know fx is equal to 5 minus 17x minus 10x square. We know this from our expression, that 5 plus 17x minus 10x square divided by x into 1 minus x into 2x plus 1 is our expression for fx that we need to integrate. So 5 plus 17x minus x square is equal to x and 1 minus x and 2x plus 1 dx. This is the expression we need to integrate. From this we can see that we cannot integrate this function. As this is in the reciprocal form, this expression is in the fraction form, we cannot integrate this. To integrate this, we need to write it out in a partial fraction. In this expression, we can see that we have the variable x in both the numerator and the denominator. In our fraction, there is x in both the upper side and the lower side of the fraction. So this cannot be integrated. That's why we need to write out this fraction as partial fraction. But we have already done that in our part A. So I will write out the equivalent partial fraction for this expression and then calculate the integration from there. Then we perform the integration. So 5 divided by x plus 4 minus x, 4 divided by 1 minus x plus 8 divided by 2x plus 1 is our equivalent partial fraction for our expression. We can see that in our partial fractions, there is only the variable x is only present in the denominator. That's why we can integrate this function. But we cannot integrate our expression given in our original expression. We cannot integrate our original expression. I can give a reference that we got this information from part A. Now, to integrate this, I have to integrate each of the term separately. So I know that the integration of 5 divided by x would be equal to 5 ln x. We know that the integration of 1 by x is equal to ln x plus c. So we are using this expression to integrate 5 by x, and we will also again use this to integrate 4 divided by 1 minus x. So we will get 4 into ln 1 minus x. But as we have assumed that this expression is equivalent to 1 by x, we need to differentiate this. We need to differentiate the denominator, and we have to then divide by that differentiation. So divided by the ddx of 1 minus x. Then plus we have 8 into ln of 2x plus 1. Again, we are assuming that this expression is 1 by x, and that's why we have to differentiate 2x plus 1 and divide by the differentiation. So divided by dx of 2x plus 1. Ultimately, we can just put the limits on this. So we will simplify this expression. Plus 4 divided by minus 1. The differentiation of 1 minus x would be 0 minus 1, which is minus 1. And 8, we know that the differentiation of 2x plus 1 will be 2 and 0. So 2 plus 0 is equal to 2. So 2 ln 2x plus 1. And the limits are present. Now further simplification will give us 5 ln x minus 4 ln 1 minus x plus 4 ln 2x plus 1 is our final expression, and then we give the limits. Now, in order to find the value of this definite integral, we need to substitute the values for 4 and 2 in our expression. So we can write 5 ln 4 minus 4 ln 4 ln 1 minus 4 plus 4 ln 2 into 4 plus 1. This is our first expression, and we will subtract 5 ln 2 minus 4 ln 1 minus 2 plus 4 ln 2 into 2 plus 1. So this is our expression for the definite integral. Calculating this will give us the value of the integral. So simplifying this, we will get 5 ln 4 minus 4 ln 3 plus 4 ln 5 as our first expression, and then we will have 5 ln 2 minus 4 ln 1 plus 4 ln 5. I'm sorry, this is 4 ln 5. Ln 5, 9, ln 9. Because 2 into 4 plus 1 is equal to 9. Now I can write 5 ln 4 as 5 ln 2 square. Writing this shows us that I can write 2 before the ln due to our rules of logarithm. So this can be written as 5 ln 4 can be written as 10 ln 2 minus our 4 ln 3, and again we can write 4 ln 9 as 4 ln 3 square, and we can bring the 2 over the 3 before the ln. So 4 2 is 8. We have 8 ln 3. We can write 9 as 3 square, and we can bring the 2 before the ln. So 4 2 is 8 ln 3 minus 5 ln 2 minus 4 ln 1. We know that ln 1 is equal to 0, so minus 4 ln will be equal to 0. Or we can just not write it. And we have 4 ln 5. Simplifying this further will give us our final answer. So I can write 10 ln 2 minus 4 ln 3 plus 8 ln 3. So minus 4 ln 3 plus 8 ln 3 will be equal to plus 4 ln 3. And we have minus 5 ln 2. Expanding the brackets, we get minus 5 ln 2 and minus 4 ln 5. We can see from here that 10 ln 2 and minus 5 ln 2 will add and give us 5 ln 2. And then we have 4 ln 3 minus 4 ln 5. We have 5 ln 2, then we can take 4 common from both these terms, and we get ln 3 minus ln 5. And then we can write ln 3 by 5. We know that due to our rules of logarithm, ln of a minus ln of b is equal to ln of a divided by b. So this is the rule we have applied here. So ultimately we can see that we have this expression as our answer to part B. We had to write our answer in the form p ln 2 plus q ln 3 by 5, and we have written this in this form. We can see that we have written this in this form. So comparing this with the form given in our question, we can say that Again, comparing this, we can see that P is equal to 5 and Q is equal to 4. So we've written our answer in the form P ln 2 plus Q ln 3 by 5, and we have also found out the values of P and Q as we are told to in the question. So this was our question number 4. At first, we wrote down our function in the form of partial fractions, and then we used those partial fractions to integrate our function, and then we used the limits to simplify our function to a given form in the question. So this was our question number 4, and this concludes our question number 4. We can now move on to number 5. Geometric equations: x equals to 3 plus 2t divided by 1 minus t, y equals to 1 minus t square. So these two are the parametric equations for our curve C. Now we can see from here the point P where t equals to 2 lies on C. For part A, we now have to use the parametric differentiation to find the equation of the normal to C at P, and we have to give our answer in the form ax plus by plus c. Okay, so we can see that we have to find an equation for the normal to our curve C at our point P. To do this, we can first find out the equation. We can first find out the gradient of the normal. Now, to find out the gradient of the normal to at point P, we first have to find out the gradient of our curve at point P. To do that, I can differentiate our expression for x, and I can differentiate our expression for y. We know that in order to find the gradient of our curve, which is given by dy by dx gives us the gradient of our curve C. In order to find dy by dx, we need to know dy by dt, and we also need to know dx by dt. If we know them individually, I can just divide and find out the value of dy by dx, or I can get the value of gradient at a certain point. So this will be our strategy. We will calculate the value of dy by dt at P, and we will calculate the value of dx by dt at P. The gradient of dx by dt and dy by dt will give us the gradient at point P. So I know the expression for x is 3 plus 2t divided by 1 minus t. This is our expression for dx by for x. If I have to find the differentiation for it, I can write. At first, I can see that this cannot be simplified any further. This fraction cannot be simplified any further. As this cannot be simplified, any expression that is like this in the quotient form, we have to use the quotient rule to differentiate this. So, as per the quotient rule, when differentiating this type of functions, we have to square the denominator, and then we have to multiply the denominator with the differentiation of the numerator. Then we will subtract the product of the numerator with the differentiation of the denominator. This is our expression for dx by dt. We will now simplify. So 1 minus in the numerator we have 1 minus t into the derivative of 3 plus 2t. The differentiation of 3 plus 2t would equal 0 plus 2 into 1. Then we have minus 3 plus 2t, and then we will multiply the differentiation of 1 minus t. The differentiation of 1 is 0, and the differentiation of minus t would be minus 1. So here we get 0 minus 1, and the denominator will stay the same, which is 1 minus t whole square. So we have 2 1 minus t, 2 into 1 minus t, minus into minus 1 plus 1, 3 plus 2t. This is just simplification at this stage. So this is 1 minus t whole square. Ultimately we get, if we simplify further, we get 2 minus 2t plus 3 plus 2t divided by 1 minus t whole square. So minus 2t and plus 2t cancel out. We get 5 by 1 minus t whole square as our expression for dx by dt. Now for our expression for dy by dt, we know that y equals to 1 minus t square. From the question, from this we can see that dy by dt would be equal to the differentiation of 1 minus the differentiation of t square. So the differentiation of 1 will be 0 and the differentiation of t square would be minus 2t. This will give us minus 2t as our answer for dy by dt. Now what we will do is we will calculate the gradient at dy. We will calculate the value for dx by dt and dy by dt at our point P. What this will do, this will simplify our process. So I can write at point P, t is equal to 0. T is equal to 2. If t is equal to 2, dx by dt would be equal to 5 divided by 1 minus 2 whole square, which ultimately is 5 divided by minus 1 whole square, which is equal to 5. Now for dy by dt, we know the expression is minus 2t. So minus 2 into 2. I'm substituting t equals to 0 in every single equation. So in place of t, there will be 2. So our expression for dy by dx was minus 2t. In place of t, I have written 2. This will give us minus 4. So now we can find out the gradient of our curve C at point P. To find this, first of all, we need to understand that this quantity, the gradient of C at point P, is represented by dy by dx. Now to calculate this quantity, we have to use dy by dt divided by dx by dt. This will ultimately give us, we know that at point P, dy by dt is equal to minus 4 and dx by dt is equal to 5. So the value for gradient the value for gradient of our curve C at point P is minus 4 by 5. We know that we have to calculate the equation of the normal. We know that normal is perpendicular to a curve at the point, which is at the point it is normal to. So we have to find the equation of the normal at point P. This means that our straight line, which we call the normal here, is perpendicular to the point P at our with our curve. So in order to find the gradient of the normal, we have to use the gradient. We have to use the gradient of dy by dx at point P, and we have to divide minus 1 by it. So I will do this. So I can do now minus 1 divided by minus 4 by 5, and this will give me 5 by 4 as the gradient of the normal at P. So now I can find out the equation of the normal. To find the equation of the normal, I need two things. One is the gradient of that line or the normal, and I also need a point on that line or our normal. For the gradient of the normal, I've already calculated it. The gradient of the normal, let's say m, is equal to 5 by 4. As for a point on our line normal on the normal, we have to calculate the point that lies on our normal. We know that the equation of the normal we need to find is a normal to the point P. So we can use the gradients of the point. We can use the coordinates of the point P to find out our equation of the normal. In order to use the coordinates, we need to have them. but in our question only the values for t is given. That's why we have to use the values of t and the equations for x and y to find the coordinates of p. I can write at t equals to 2, x is equal to, let me see the expression for it, 3 plus 2t divided by 1 minus 3t. So 3 plus 2 into 2 divided by 1 minus 2. This will give me 3 plus 4 divided by minus 1, or 7 divided by minus 1 minus 7. Okay, so this is the x coordinate of p. Now for the x coordinate of y, we have to use the expression for y and we have to substitute t equals to 2 in place of t. So the expression for y is 1 minus t square. So we have t equals to 2, so 1 minus 2 square. This will give us 1 minus 4 or minus 3. So the coordinates of point P is minus 7 and minus 3. Now we can use these values to find our equation of the normal. We can write y minus of minus 3 equals to m, which is 5 by 4, into x minus of minus 7. This will give us 5 by 4 x plus 7 in the brackets. Expanding will give us 5 by 4x plus 35 divided by 4. Further simplification is not required. Further simplification is required because we have to give our equation in the form ax plus by plus c. So I can multiply by 4 on both sides. Multiplying by 4 on both sides will give us 4y plus 12 equals to 5x plus 35. Bringing all the terms to the left will give us 5x plus 4y plus 12 minus 35 equals to 0. So this will be 5x plus 4y minus 23 equals to 0. Now multiplying by minus 1 on both sides will give us 5x minus 4y plus 23 equals to 0. And this is our equation for the normal. So this was the process for finding the equation of the normal. At first, we figured out an expression for dy by dt and dx by dt, and we used those expressions to find the value for dx by dt and dy by dt at t equals to 2. Basically, basically at point P. Then we use those values for dy by dt and dx by dt to find dy by dx. The gradient we used dy by dx to find out the gradient at point P. We use the gradient of point P to find the gradient of the normal, and then in order to find the equation of the normal, we used the parametric equations to find the coordinates of point P. We use the coordinates of point P and the gradient from our answer to calculate the equation of the normal. So this was our whole part A. For part B, we now have to show that a Cartesian equation for C can be expressed in the form y equals to px plus q divided by x plus r whole square. So what we can see from here is that there are two parametric equations, and we need to write one equations in terms of x and y. We need to relate the two variables x and y from our parametric equations. So in order to do that, I need to substitute the value of t into another equation to find out this. So for part B, I know the expression for x is 3 plus 2t divided by 1 minus t, and the expression for y in terms of t is 1 minus t square. So I can write x into 1 minus t is equal to 3 plus 2t. So x minus xt will be equal to 3 plus 2t. Again, bringing all the x terms to the left will give us x minus t minus 2t will give us 3 minus x. Taking t, we can see that t is common in both the terms. We can take t common. This will give us minus x minus 2, 3 minus x. We get t is equal to 3 minus x divided by minus x minus 2. I can take minus 1 common from the numerator. This will give me x minus 3, and minus 1 common from the denominator. This will give me x plus 2. Ultimately, after simplifying, we get t is equal to x minus 3 x plus 2. I can use this expression for t, and I can substitute this expression into our equation for y. And this what this will do, this will relate our y and x terms directly without the use of t. So substituting this into our equation will give us x minus 3 and x plus 2 whole square. So from this we get x minus 3 whole square divided by x plus 2 whole square. The property of squares: if there are two numbers in a fraction, and the fraction is squared, or the fraction has any power on the whole of it, we can write this fraction as a to the power of n divided by b to the power of n. The power will be distributed on the numerator and the denominator equally. So this is our expression. So this is the identity that I used to simplify from the step 2 to step 3. Now I can further simplify. I can combine these fractions. This will give me I can now expand and simplify. So x square plus 2x, plus 4x plus 4 minus x square minus 6x plus 9 x plus 2 whole square. Now this will equal x square plus 4x plus 4 minus x square plus 6 and minus 9. So this is our simplified equation. This is our simplified equation for y. We can see that in this equation there is only y and there is only x. So this is our expression, a Cartesian expression that links only y and x together. So from this we can see that we can easily find out the values for p, q, r, and k. So if we compare this with this, px plus q divided by x plus r whole square, x is not equals to k. We can see that from here, if we compare the sides, we can say that p is equal to 10 and q is equal to minus 5. Then we can say that r is equal to 2 and k is equal to minus 2. The reason why k is equal to minus 2 is because k is the value that needs to be excluded. We know that in a reciprocal function like this, or in a algebraic fraction like this, we need to exclude certain values from our denominators. In our case, we have x plus 2 whole square as our denominator. We have to exclude the values of x for which this whole denominator is equal to 0. The values of x that causes this expression to be 0 needs to be excluded. From this we can see that x plus 2 is equal to 0 and x equals to minus 2. So x equals to minus 2 is the value that needs to be excluded from our expression. And from the question we can see that it is mentioned that x is not equal to k, meaning that the value that needs to be excluded is k. So k is equal to 2. k is equal to minus 2, as I have written here. So this is our answer. So this is our answer for part B, and this concludes our question number 5. We can now move to question number 6. That it is said, relative to a fixed origin O, the point A has a position vector of 1i plus 2j minus 3k, and point B has a position vector of 5i plus 2j plus 1k. So from this we get OA and OB. This is the value of OA and this is the value of OB. These are also coordinates of point A and point B if I, j, and k are thought of as parallel vectors in 3 dimension. Now it is said that the line L passes through A and B, and now in part A we have to write down a vector equation for L. In part A, it is said that a line passes through 2 points, point A and point B. We know for point A, we already know its position vector, and we also know the position vector of B. For writing down a vector equation, we need two things. First, we need a point on that line, and second, we need a vector that is parallel to that line. In our case, we can see that we already know the position vector of A and B, both of which are on the line. So I can use either of them to find my equation. Now I need a vector equation that is parallel to that line. We can see from these that our vector AB is also parallel to our line. So we can use the vector AB as the parallel vector to write our equation. So to find AB, I can write that AB is equal to OB minus OA. Vector AB is equal to OB minus OA. We know that OB is equal to, from our question, 5i plus 2j plus 1k. 5i hat plus 2j plus 1k. This is our OB. We can now subtract OA from this. OA is equal to 1i plus 2j minus 3k. 1i plus 2j minus 3k. Simplifying this, we get plus 2j plus k minus I minus 2j and plus 3k. Ultimately, we get 4i and 2j and plus 2j and minus 2j, they cancel out. So ultimately our answer is 4i and plus 4k. This will be our vector AB. Now our vector equation will be equal to OA, a point on the line, and lambda AB, the vector that is parallel to that line. OA is equal to I plus 2j minus 3k lambda into 4i plus 4k. So this is our answer to part A. We do not need to simplify this or expand the brackets because this is because we are told to write down the vector equation. So we've written down it. We do not need to simplify it further. Now for part B, we are given that we can see that it is given that point C has a position vector of 3i plus alpha j plus 5k, where alpha is a constant, and the point A, B, and C form a triangle ABC. The angle BAC is 45, and now we have to find the exact possible values of alpha. So now for our part B, we can see that given also that the point C has a position vector of 3i plus alpha j plus 5k, where alpha is a constant, and the points A, B, and C form a triangle ABC. The angle BAC is also given, and the BAC is equal to 45. Now we have to find the exact values of alpha. So from part A, we know that there is a line L and A and B is a point on that line. So C lies somewhere around this line, and it is said that the point C together with the points A and B form a triangle, and the angle BA and C, this angle is equal to 45. From here, we we can see that we know the position vectors of OA, we know OB, and we know OC, and we also know the vector AB from our part A. From this we can see that we can use the dot product. We can use the dot product of AC and AB together with the angle 45 to find the value for alpha. So we can write AB dot product of AC will be equal to the magnitude of AB into the magnitude of AC into cos of 45. Now we have to calculate each of these terms. In our dot product, we already know the value of AB. We have to find out the value of AC. We know AC is equals to OC minus OA. OC is equal to 3i plus alpha j plus 5k. So 3i plus alpha j plus 5k is OC minus OA is OA as a position vector of I plus 2j plus 3k. This will become minus I minus 2j minus 3k. Minus 3k will become plus 3k. So simplifying will give us 2i plus alpha minus 2j and 5 plus 3 8k. This will be the vector AC. Now we can find the magnitude of AB. The magnitude of AB would be root over the coefficient of I squared the coefficient of j. We know that from part A, we know that AB is equal to 4i plus 4 plus 4k. We know that. So the magnitude of AB would be 4 square plus 4 square. We take the coefficient of I, j, and k and we square them, sum them up, and then we root them to find the magnitude. So the magnitude would be equal to 4 root 2 for AB. For AC, its magnitude will be equal to root over 2 square the coefficient of I, then alpha minus 2 whole square the coefficient of j, and the 8 square the coefficient of k. Now we can simplify this. Simplifying this gives us 68 plus alpha minus 2 whole square root on the above. So we now know the magnitude of AB, the magnitude of AC, and we also know the vector AC. So we can multiply this. So we can put this in our dot product. We know the dot product is equal to AB into AC equals to the magnitude of AB into the magnitude of AC into cos of 45. In the right hand side, I can input all the values here. 4 root 2 into root over 68 minus alpha, sorry, plus alpha minus 2 whole square into cos 45, which is root 2 by 2. On the right hand side, sorry, on the left hand side, we have AB and AC. We know AB and AC in terms of I, j, and k vector. So when calculating dot product, we can multiply the coefficients of I from both vectors, and we can multiply the coefficients of j from both vectors, and we can multiply the coefficient of k from both vectors to find the dot product. So we can write that we know that AB is equal to, so we can write the two vectors in vector form. We know that AB is equal to 4i, 0j and 4k. We know AC is equal to 2i, alpha j and 8k. This is equal to AC. So now we can multiply the corresponding values for I, j and k variable k vectors. This will give us a value for our dot product. So 4 into 2 plus 0 into alpha plus 4 into 8 is equal to 4 root 2 into 2 root 2, which will give us 4, and root over 68 plus alpha minus 2 whole square. Simplifying the left hand side will give us 4 2s are 8 plus 32 equals to 4 root over 68 plus alpha minus 2 whole square, or 40 by 4 is equal to root over 68 plus alpha minus 2 whole square. We get 10 square. We are squaring the sides, we are squaring both sides. This gives us 10 square equals to 68 plus alpha minus 2 whole square, or 100 minus 68 equals to alpha square. We are expanding alpha minus 2 whole square using a minus b formulae. So this gives us 32 is equal to alpha square minus 4 alpha plus 4, or I can write that alpha square minus 4 alpha minus 28 is equal to 0. Now we can see that if we solve this equation, we will get the values of alpha for which our equation is satisfied. We see that we see that alpha square minus 4 alpha minus 28 is a quadratic equation. So we have to solve it using the methods for solving quadratic equation. To solve this equation, we can use the middle term method. We have 28 here. We can write 28 as 7 into 4, but that will not give us 4. So we can see that middle term will not work here. So instead we can use the quadratic formula. The quadratic formula states that alpha is equal to minus b plus minus b square minus 4ac divided by 2a. We know from our equation that a, the coefficient of the x square term, is 1, b, the coefficient of the x term is minus 4, and c, the coefficient for the constant term is minus 28. And we can put this into our equation. So minus of minus 4 plus minus root over minus 4 whole square minus 4 into 1 into minus 28 divided by 2 into 1 gives us our value of alpha. This gives us a value of 2 plus minus 4 root 2, and this is our answer. From this we can see that there are two possible values of alpha. One is 2 plus 4 root 2, another is 2 minus 4 root 2. So this concludes our question number 6, and we can now move on to our question number 7. Question number 7, we can see that in part A, we have to show that the substitution u equals to tan x transforms this integration, the integration of this expression to the display integration of this expression, we can see that um, we can see that all the x variables here are transformed to all the u variables here. Even the dx term has been changed to du term. Keeping this in mind, we can now start solving our part A. So for part A, I will write down the expression given in the question, which is 10x plus 10 cube x divided by 4 plus sec square x to the power of 3. And we have to transform this using a substitution that is given as u equals to 10x. We have to transform this expression to this one, and we can see that again we can see that all the x variables and their functions and the respective functions, for example the 10x function and the x square x function, all of them has been transformed to the u functions. So keeping this in mind, we can see that we can easily substitute u for the 10x for 10x, and we can also substitute u for 10 cube x. But in order to substitute a value of u in our sec square x term, we need to find out what sec square x is equal to in terms of u from an trigonometric identity. We need to find out the equivalent substitution that we need to use for u in terms of u for sec square x. So we know an identity that sec square x is equal to 1 plus 10 square x. We know of this identity. From this we can see that we can substitute u in place of 10x. So here we have 1 plus 10 square x. We know that 10x equals to u, so we can write 1 plus u square is equal to sec square x. So now we can see that we can use this expression and this expression to substitute tan x and sec x square x from our expression, and we can write our expressions in terms of u. But we also have to substitute dx with du. In order to do that, I will differentiate our function u equals to tan x. So I will integrate this function, differentiate this function. So taking du by dx, we get ddx of 10x. Now ddx of 10x will be equal to sec square x. We already know that sec square x is equal to 1 plus u square. So ultimately we see that du by dx is equal to 1 plus u square. So dx will be equal to 1 by 1 plus u square into du. Now we have all the necessary substitutions in order to write this expression as, as per required by the question. So we will substitute 10x with u. This will give us u plus u cube divided by 4 plus, in place of sec square x, I will substitute it with 1 plus u square. To the power of cube. In place of dx, I will substitute it with 1 by 1 plus u square into du. Now I can simplify the numerator in our first fraction. I can simplify this expression. U is common in both of these terms, so I can write u into 1 plus u square divided by 4 plus 1 is 5. So we have 5 plus u square to the power of cube as the denominator in our first fraction. On the second fraction, we have 1 divided by 1 plus u square du. From this, we can see that 1 plus u is a common term in the numerator and the denominator of the two opposite fractions. So we can cancel them out. This will give us u divided by 5 plus u square to the power of cube du as our simplified expression for the integration. And we can see that the format we have as our answer is exactly similar to the one that is required by the question. So just we can just compare this with the one given in our question. Now we can compare these two expressions and we can write that k is equal to 5 and n is equal to 3. N is the power on the expression in our denominator. N is the power on k plus u square, and here our the power on 5 plus u square is 3. So n is equal to 3. So this is our answer for part A. Now for part B, we have to find the integral for the original expression. We've already simplified our expression by using substitution, so we can just perform the integration from that step. Now for part B, we can write, in part B in our question we are told to find the integration of 10x plus 10 cube x divided by 4 plus 6 square x to the power of cube dx. So this is what we are told to calculate. We can see that this expression is exactly the expression in part A that we transformed to u. As we have already simplified our expression using the substitution u equals to d, u equals to 10x, we can just write it out here. And I can give the reference from part A. Now we can find the integration of this, and this will be equal to the integration of our expression. Now to solve this inequality, we can use the substitution method for integration. We can say that z is equal to 5 plus u square, and dz by du would be equal to 2u, or dz would be equal to 2u du. Now I can use the substitutions to substitute my expression. I can write half 2u divided by 5 plus u square to the power of cube du. I can write half outside our integral sign because I have bought a 2 with our u. The 2 and the half, they cancel each other out, and that's why our expression in step 1 and step 2 are equal. So now I can substitute 5 plus u square with z. So this I can write half is equal to, and I can also substitute dz in place of 2u and du. I can take the product of 2u and du, and I can substitute z in place of them. So this will give us 1 by z cube into dz. The reason we are doing our integration in this method is because this will be easier in this way. So ultimately, if we integrate this function now, we will get z minus 3 divided by z minus 3 inside our integration function, which will ultimately give us half into z minus 2 divided by minus 2. The x will be in the power of x, the exponent of x will be increased by 1, and the whole thing would be divided by the new power. So if we have increased the power of z to minus 2, so it has increased by 1, and we are dividing z to the power of minus 2 by minus 2, and then we will have a constant of integration. We can simplify this, so minus 1 by 4 z to the power of minus 2 plus c is our expression. We know that z is equal to 5 plus 2u square, so we can substitute this in our expression. Plus c, and we also know that u is 10x, so we have used the substitution method 2 times here. So this will give us 1 by 4 5 plus 10 square x plus c, and this is our answer. We also have to write a minus 2 here. This will be continued here and here. We missed this in our previous step. So this is our answer for part B of question number 7. For question number 7, at first we use the simplification from our part A, and then we use that simplification to further simplify, and then we use substitution to further simplify our simplified expression in order for us to easily calculate the integration. From here we can see that we got half into z to the power of minus 2 divided by minus 2 as our expression for the answer of integration, and then we substituted the value of z into our expression. And we also know that u itself is a substitution for 10x, so we again substituted 10x in place of u. Ultimately we have this expression for the integration of our original function. So this concludes our question number 7. We can now move on to question number 8. So this is our question number 8. We can see that in part A, we have to find in ascending powers of x the first 3 non-zero terms of the binomial series expansion of 1 by root over 4 plus x. We know that when doing binomial series expansion, the series expansion can have finite number of terms and infinite number of terms. There are two ways to calculate the series expansion, and the ways depend upon the exponent on our expression. For part A, we can see that we have to calculate the series expansion for 1 divided by root over 4 plus x. From here, I can write down that this is equivalent to 1 divided by 4 plus x to the power of half. We can see here that 4 plus x to the power of half can represent root over 4 plus x. They're equivalent. We also know that a reciprocal or a fraction can be represented by a negative power. So we can write this as 4 plus x to the power of minus half. Here we can see that we need to find the binomial series expansion for this expression. We also see that the exponent on this expression is minus half. As the exponent or n is less than 0 and it is a fraction, we have to calculate the series expansion in the form 1 plus ax to the power of n. So we have to write down 4 plus x to the power of minus half in this form, where the series expansion for this would follow this formula: 1 plus n into x plus n into n minus 1 with factorial of divided by factorial of 2 into a x square, and so on. Our expansion will follow this formula. The reason why we are using this method to calculate our expansion is because the power or the exponent in our expression is negative and it is in a fraction. If the exponent was not negative, or if the integer was an integer, we could use the other method where we use the combinatrix and Pascal's triangle to find out all the terms. But as the exponent is negative, we will have an infinite number of terms for our binomial series expansion. That's why we have to use this method. We first have to write down 4 plus x to the power of minus half in this form, and then we have to use this formula to find out our binomial series expansion. So now I can write 4 plus x to the power of minus half as, I can take 4 common. So this will give me 1 plus x by 4 whole minus half. Simplifying, we get 4 to the power of minus half and 1 plus x divided by 4 to the power of minus half. The power minus half is transferred to both 4 and 1 plus x by 4 because of the power rule we know. We know that a into b to the whole to the power of half is equal to a half into b half. And this is the rule we have used here for our calculation. We can see that 4 into 1 plus x by 4 to the whole power of minus half is equal to 4 to the power of minus half into 1 plus x to the power of 4 to the power of minus half. Simplifying this, we get 1 by 2, and for 1 plus x by 4 to the power of minus half, I can just calculate the binomial series expansion. So abiding by our formula, we can do this expansion. The first term will be 1, then the second term is nx, n is minus half, and x is x by 4. Now the third term will be n into n minus 1 divided by the factorial of 2 into x divided by 4 whole square. We can see from our question that we only need to find the first 3 non-zero terms of the binomial series expansion. And these are the first 3 terms. This is our expansion. Now we can simplify inside the brackets. So 1 minus x by 8, and then we have plus minus half into minus 3 by 2 will give us 3 by 4 divided by 2, 3 by 8. This is equal to 3 by 128. X square, and the series will continue. Now I can expand between the brackets. I can expand half into the brackets, so this will give me half into minus x by 8 would be equal to minus x by 16. Half into plus 3 by 128 will be equal to 3 by 256 x square, and the series will go on. And this is our binomial series expansion of the expression 1 by root over 4 plus x. And this is our answer for part A. For part B, we have to use the expansion from part A, and we have to state the first three non-zero terms. We can simplify this as 1 by 4 minus x to the power of half, and then we can write 4 minus x to the power of minus half. Ultimately, we will get 4 to the power of minus half, 1 of plus minus x to the power of minus half. And this is the term we need to expand. Now, seeing this, we can realize that 1 plus, in our previous question, we had to use 1 plus x by 4 to find out our series expansion. But here we have minus x by 4 instead of x by 4. What this means is that our series expansion will be exactly the same, but instead of using plus x by 4, we are now using minus x by 4. What this means is that our first term will not change because our first term does not have any x. It is a constant term. For our second term, we can see that we multiplied minus half and plus x by 4 in our part A. For part B, we have minus x by 4 as our x term. So we can see that our second term will be positive instead of being negative in part B. For part C, for term number 3, we can see that even if our x is minus, as there is a power of 2 on the whole expression, or on the whole fraction, the value of x by 4 does not matter. For plus x by 4, the value is the same for the third term, and for minus x by 4, the value will be the same. The sign for the third term will be the same. That's why we understand that the only thing that changes due to this change in our expression is the second term. The second term was negative. Now in part B, the second term would be positive. So if we can elaborate, for part B, the expression that we need to expand is 1 plus of minus x by 4 to the power of minus half. In part A, we expanded this expression. But in part B, we have to expand this one. The difference is that in part A, we used plus x by 4. In part B, we are using minus x by 4. So the expansion would be 1 minus half into minus x by 4, plus the second term will be the same because the second term contains a square over the minus x by 4 term. So this will make it positive. This will give us no change for the second term. So this gives us 1 plus x by 8 and plus the third term, which is 128 x cubed. Now this is just to show that the only thing that changes, we can from part A, I can, if I need to compare, in part A, the expansion we had was 1 minus x by 8 plus 3 by 128. So the only term that was affected by this change was our second term. So now if we understand this, we can write down the actual expansion for part B. We can write down the actual expression for part B. So we can write that 1 divided by root over 4 minus x is equivalent to 1 minus x by 8. Remember that our second term will have a flipped sign. The expansion was half minus x by 16. So the sign for the second term will be flipped. So instead of minus x by 16, this will be plus x by 16. The third term will be the same as before, 3 by 256 plus x square, and the rest of the series. So this was our part B. In part B, we just have to state the first three non-zero terms, and our marks is that's why our marks is 1. Now for part C, we can use part B, or we can use any other method to show that 1 by root over 4 plus x into 1 by root over 4 minus x will give us a plus b x squared, where a and b are fully simplified fractions. So we can write that 1 divided by 4 plus x into 1 divided by 4 minus x will be equal to the expansion of our first expression into the expression of our second expression. Multiplying these two expansions will give us the value for a plus bx square. So we write that for our first expression, our expansion was 1 minus x by 16 plus 3 by 256 x square, and the rest of the series. And we multiply this with the second series. The second series is 1 plus x by 16 plus 3 by 256 x square, and the rest of the series. So this is half. This was half, and this will also be half. Because there was half in our answer. So now we will just expand. Now we will just expand to find the expansion, to find the product of these two expressions. So I will multiply this with this. So we get half into half, then half into x by 16. First I will take half, then we will get half into half plus half into 16 x by 16, and then we will have half into 3 by 256 x square. Then we have minus x by 16. We will multiply minus x by 16 with half again, and then we'll multiply minus x by 16 with minus x by 16. So this will give us minus x by 16 into x by 16. And then we can multiply minus x by 16 with plus 3 by 256 x square. We can see that doing this gives us a term that has x cube. We can see that doing this will give us a term that has an x cube variable. We know that in our question we only need to write our answer up to x square. That's why we can ignore that term. We can ignore this term. Then I can take 3 by 256 x square and I can multiply it with half. So this will give me plus 3 by 256 x square into half. And then I can multiply 3 by 256 x square with x by 16. Again, I can see that doing this, multiplying 3 by 256 x square with x by 16 will give us a term, will give us a x cube term. But we do not need the x cube term. We only need up to x square. That's why we can ignore that also. So now simplifying this will give us half into half is 1 plus 1 by 4, and then half into x by 16 is x by is x by 32, and then I can write that minus x by 16 into half would be equal to minus x by 32. Then we have half into 3 by 256 x square. This will give us plus 3 by 512 x square, and again minus x by 16 into x by 16 would give us minus x square by 256, and then again we can simplify the last term. 3 by 256 x square into half would be equal to 3 by 251 512 x square. Now we can simplify this. When simplifying, I can see that our first term is 1 by 4. For our next term, x by 32 minus x by 32, they cancel out. So there will be no x term in our expansion, or our product for these two expressions. And then we can simplify our x square terms. And this will give us 1 by 128 x square as our function. We have to know that, we have to understand that this series is infinite. That's why all the other terms are present, but we are not writing them because that is not relevant to our question. Now we can, by seeing this, we can say that our expressions 1 divided by root over 4 plus x into 1 divided by root over 4 minus x is approximately equal to 1 by 4 plus 1 by 128 x square. So this is our answer to part C. So this is our answer to part C. We can now move to part number D. In part D, we have to use the expression from part C with x equals to 1, and we have, using x equals to 1, we have to show, we have to find an approximation for root over 135. We have to show our working. So we have to use our expression in C, and we have to use x equals to 1 to find out an approximate value for root over 135. Okay, so we can start solving this. So for part D, we have the expression from part C, which is root over 1 by root over 4 plus x into 1 by root over 4 minus x is actually equal to 1 by 4 plus 128 x square. Now we have to use x equals to 1 to find an expression, an approximation for root over 135. So we can use our value for x, which is x equals to 1, in our expression. So this will give us 1 divided by root over 4 plus 1 into 1 divided by root over 4 minus 1 on the left side, and on the right side we get 1 by 4 plus 1 by 128 into 1 square. On the left side we can simplify. This is 1 by root 5 into 1 by root 3. 4 plus 1 is 5 and 4 minus 1 is 3. So we get 1 by root 5 into 1 by root 3 is equal to 1 by 4 plus 1 by 128. We know that 1 square is 1, so the right side will be equal to this. Then we can further simplify. We can see that 1 by root 15 is equal to 1 by 4 plus 1 by 128. From this we can see that the reason why I can write root 5 into root 3 as root 15 is because multiplying the root of something with the root of another thing is equal to the root over of their product. That's why I can combine root 5 into root 3 as root over 5 into 3, which is root 15. Now we have this expression, we can further simplify. This will give us 1 by root 15 is equal to 33 divided by 128. So from this we can see that root 15 is actually equal to 128 by 33. In our question, we can see that we had to find out the value for 135, root over 135, but using x equals to 1, we see that we can only find the value of root 15. If we try to express root 135 in terms of root 15, we can see that 135 is equal to 15 into 9. So separating out the terms would be root 5 into root 9. We know the value of root 9, which is 3. So we can see from here that root 135 is actually equal to 3 into root 15. From our expression, we have calculated an approximation for root 15. So we can substitute this value and multiply 3 with it to find an approximation for root 135. We know the approximation for root 15 is 128 divided by 33. So ultimately, the answer we get is 128 divided by 11 for the approximation of root over 135. This is our answer for part C. This is our answer for part D, and this concludes our question number 8. We can now move to number 9. We can see that we have two figures here, figure 1 and figure 2. In figure 1, it shows a sketch of part of the curve C with equation y equals to cos x plus 1 by 5 e to the power of x. The finite region shown shaded in figure 1 is bounded by the curve C, the y-axis, the x-axis, and the line with equation x equals to 4. This part. Now, this region is rotated through 2 pi radians about the x-axis to form a solid S. Now we have to show that the exact volume of S is given by this expression. So from the question we can understand that this shaded area has been rotated about the x-axis, and a solid has been formed around a 3D solid has been formed around the x-axis, and we now have to find the volume of that solid S using integration. So we can start solving this. We know that in order to find volume, we have to use the formula pi integration of y square dx. This formula will give us the volume, for a solid that has been rotated around the x-axis. As per the question, we know that this shaded region was rotated around the x-axis to form the shape. So we can use the limits for this shaded area to find the volume of our object. So the limits for this shaded area, which is 4 and 0, will be the limits for our integration to find volume. So 4, 0 is our limits. Now from the question we know that y is equal to cos x plus 1 by 5 e to the power of x. We know this, that y is equal to cos x plus 1 by 5 e to the power of x. And we can see that in our formula we have to use the square of y. We need to use y square. So I can, before substituting y in our expression for volume, we can find out the value for y, the expression for y square. So y equals to cos x plus 1 by 5 e to the power of x. So y square will be equal to cos x plus 1 by 5 e to the power of x whole square. We can see that as both of the terms are added together, squaring both of them together will give us an expanded value, and we need to expand this using the a plus b whole square formula. Doing this will give us a squared plus 2 into a into b plus b square. So cos x squared is equal to cos x square x plus 2 cos x into 1 by 5 e to the power of x is equal to 2 by 5 cos x e to the power of x, and 1 by 5 e to the power of x whole square is equal to 1 by 5 square into e to the power of x squared. So 1 by 5 square is equal to 1 by 25, and e to the power of x is equal to e to the power of 2x. E to the power of x whole square is equal to e to the power of 2x. The reason for this is that if there is a base upon which is a power, and if there is a power on the whole expression, let's say n, this can be simplified as m into n. So this is what we have done here. A to the power of x whole square is equal to e to the power of x into 2. So this is our simplified equation for the volume. And now we can substitute this in place of y square. Before substituting, we can see that our expression for y square contains x cos square x. We know that when a trigonometric expression or function is squared, we cannot differentiate that function. We cannot integrate that function. In order to integrate this type of functions where the trigonometric function has been squared or cubed, we need to convert these trigonometric terms into the linear terms, into a linear terms for trigonometric, into linear trigonometric terms. So we can see that we have cos square x in our expression. We cannot differentiate this, we cannot integrate this function, so we need to write an equivalent linear trigonometric expression for cos square x. To do that, I can use an identity. We know that cos 2x is equal to cos square 2 cos square x minus 1. We know this from the identity of cos 2x. From this we can see that cos 2x, from this we can see that cos square x will be equal to, I can write it down on the next page. So we know that cos 2x is equal to 2 cos square x minus 1. This is an identity for cos 2x. Now from this we can see that cos 2x plus 1 is equal to 2 cos square x, and cos square x is equal to cos 2x plus 1 divided by 2. The special feature for the of this equation is that we know from this that cos square x is equal to a linear cos 2x plus 1 divided by 2. So we can replace cos square x with cos 2x plus 1 divided by 2 in our expression. This will give us cos 2x plus 1 divided by 2 plus 2 by 5 cos x e to the power of x plus 1 by 25 e to the power of 2x. Ultimately, the simplified expression for a y square will equal, so the simplified equation for y square is equal to half plus half cos 2x. From here we are separating out cos 2x plus plus 1 divided by 2. We are separating these terms out, so we get half plus half cos 2x plus 2 by 5 cos x ex plus 1 by 5 e to the power of 2x, 1 by 25 e to the power of 2x. This is our simplified expression for y square. So we can now substitute this expression for y square into our volume formula. We know that our volume formula was integration of y square in terms of dx, and the limits are 4 and 0. We can substitute in this expression half plus half cos 2x plus 2 by 5 cos x e to the power of x plus 1 by 25 e to the power of 2x. This is our expression that we need to integrate in order to find our volume, and the limits for this is 4 and 0. From our question is, we can see that we are told to derive this expression, and we have derived this expression. As we have derived this expression, this is our answer to part A. In part A, we were only told to derive this expression, and we have derived this expression. So the majority of the work here was to simplify y square. So this concludes our part A. For part B, we have to find e to the power of x cos x dx. To find this, we can see that the two terms that are multiplied together in this expression is e to the power of x and cos x. As the two of them are different functions, they cannot be simplified and written in algebraic form. As they cannot be simplified, we cannot integrate them in any normal way. We can use integration by parts to differentiate them. To integrate by using the parts method, so we first have to take our first term, which is ex, and then we have to multiply it with the integration of our second term, which is cos x dx. And then we will subtract the integration with the ddx of e to the power of x, the first term, and then we will multiply the integration of our second term to it. The whole of this will be integrated. So simplifying, we get e to the power of x into the integration of cos x will be equal to sin x. Then we have the differentiation of e to the power of x, and the integration of cos x would be equal to sin x dx. Now we see that the integration term we have here, the integration term we have here itself cannot be simplified further. That's why we also have to integrate this using integration by parts. So for the next step, we will write e to the power of x into sin x because this has not changed, and we'll perform integration by parts for this expression. So this will give us e to the power of x in brackets. This will give us e to the power of x. We take the first term and then we multiply it with the integration of the second term, and then we subtract, and then we take the differentiation of the first term, and then we integrate, and we multiply with the integration of the second term. This whole thing again will be differentiated. This gives us e to the power of x sine into sin x minus, inside the brackets we can simplify, e to the power of x into, we know the integration of sine x is equal to minus cos x, and on the last term we can simplify inside the integral sign as, so ddx of e to the power of x is e to the power of x, and the integration of sine x is minus cos x, then we have dx, and we close the bracket. Again simplification, this gives us minus e to the power of x cos x minus, from this term we get the integration of e to the power of x cos x dx. The minus sign here comes before the integral sign. When it comes before the integral sign, the minus sign outside and the minus sign from inside, they multiply together to form a positive sign here. So we can see that we are left with this inside the bracket. I can now expand the bracket. This will give us ex into sin x. So ex into sin x minus, sorry, plus, we are expanding the bracket, plus e to the power of x cos x plus e to the power of x cos x dx. I'm sorry, this will be negative because we are expanding the brackets, is equal to e to the power of x cos dx. We can see that we have the same term on our right and on our left. What we can do, we can combine those terms, we can bring those terms together. So this will give us 2 e to the power of x cos x dx on the left, and e to the power of x sin x plus e to the power of x cos x on the right. So now we can divide both sides by 2 to find out the value for integration of ex to the ex cos x. So half e to the power of x sin x plus half e to the power of x cos x. And this is our answer for part B. This is the result for the integration of e to the power of x cos x dx. And as we are integrating this function, we need to add an constant of integration. So this is our expression for the integration of e to the power of x cos x. We can give our answer like this, or we can take e to the half e to the power of x common, and we can write a simplified form of this answer. So half e to the power x is common in both of the terms, so sin x and cos x plus c. So this is our finalized expression for the integration. So for part C, we can see that the figure 2 represents a paperweight formed by joining two of these solids together. The paperweight is 8 centimeter high. Now we have to use our answers to part A and part B, and we have to find by algebraic integration the volume of the paperweight, giving our answer to two significant figures. So we need to find the volume of this object, and this object is made by joining two of our S solids. We have an expression for the volume of this for the volume of this solid S in our part A. So we can integrate this expression, and the answer to this integration will be the volume of our solid S. And for the whole volume of this object, we need to double the volume of our volume S. So for part C, I can say that the volume of S, I can say that the volume of S, I can write it down in the next page. So I can say for part C, I can say that volume of our solid S is equal to pi into integration of with the limits for 0 into half plus half cos 2x plus 2 by 5 cos 2x cos x e to the power of x plus 1 by 25 e to the power of 2x dx. This is our expression from our part A. Integrating this function, this expression will give us the volume of solid S. So we will integrate this. To integrate this function, we have to integrate each part individually. So I can write integration for this whole expression is equal to pi integration of half plus half cos 2x dx plus pi integration of 4 0 2 by 5 cos x e to the power of x dx plus pi integration of 4 and 0 1 by 25 e to the power of 2x dx. Integrating these terms individually will make our calculation much more easier, and we can avoid mistakes in this way. So now we can integrate this. So integration of half plus half cos 2x will give us half x plus half the integration of cos 2x, which is sin 2x divided by divided by the differentiation of 2x, which is 2. The limit will be 4 and 0. For the next part, I can see that in this expression 2 by 5 is a factor, that is multiplied, is a constant that is multiplied with the expression. So I can write 2 by 5 before the integration sign. So 2 by 5 pi with the integration of e to the power of x cos x dx. And the last term can be simplified to 1 by 25 pi and 4 0 e to the power of 2x dx. Again, I can write it down: pi half x plus half into sine 2x divided by 2 with our limits 4 and 0 plus 2 by 5 pi. The integration of this will be equal to, we can we can see that this expression is exactly the expression we integrated in our part B. See, in our part B we integrated the same expression, and we calculated the answer. The answer to the expression was half e to the power of x sine x plus cos x. So I can write it down here: half e to the power of x sine x plus cos x with the limits 4 and 0. Then again I can simplify 25 divided by 20 pi divided by 25, and the integration of e to the power of 2x would be e to the power of 2x, but we have to divide by the differentiation of 2x. The differentiation of 2x would be 2. This is our expression. So now we can calculate the value for them individually, or we can combine them. I'm going to calculate the value of them individually. So we have to put x equals to 4 in our expression, and then we have to subtract x equals to 0 from our equation, and we will do this for every single term. So for the first term, I can substitute x equals to 4. So half into 4 plus 1 by 4 into sine 2 into 4 is our first term, and then we have to minus half into 0 plus 1 by 4 sine 2 into 0. This will be for the first term. For the second term, I have 25 pi, and inside the brackets I have half e to the power of 4 sine 4 plus cos 4 minus half e to the power of 0 into sine 0 plus cos 0. This is our second term. For the third term, I can enter e to the power of 2 into 4 divided by 2 minus e to the power of 2 into 0 divided by 2. Now calculating this, we get pi into, inside the brackets we get so now this gives us 2 plus sine 8 by 4 minus 0. Then I have 2 by 5 pi into half e to the power of 4 sine 4 plus cos 4 minus half into 1, or half. Then for the last term I have pi by 25 into into e to the power of 8 by 2 minus 1 by 2. Now I can just simplify. This will give me 2 pi plus pi sine 8 by 4 plus 2 by 5 pi. This will give us 2 by 5 pi into 1 by 2 e to the power of 4. So 2 by 5 pi into 1 by 2 e to the power of 4 sine 4 plus cos 4 minus 1 by 2 to the power of 2 by 5 pi plus pi divided by 25 into e to the power of 8 divided by 2 minus half into pi divided by 25. Now we do not need to simplify this further. No, we can simplify this further, but we do not need to completely find an expression. We don't need to write the exact value. That's why we will use an approximate value after we simplify a bit. So this will give us 2 pi plus pi sine 8 divided by 4 and plus 2 by 5 pi into half pi would be equal to 2 by 10, which is 1 by 5 pi e to the power of 4 sine 4 plus 1 by 5 pi e to the power of 4 cos 4 minus 1 by 5 pi plus pi by 50 e to the power of 8 minus pi by 50. So simplifying all the pi terms, right, we get 89 by 50 pi plus pi sine 8 by 4 plus 1/5 pi e to the power of 4 sine 4 plus 1 by 5 pi e to the power of 4 cos 4 and plus pi by 50 e to the power of 8. And this will give us, from the calculator we can calculate that this will give us, so this gives us 89 by 50, sorry, this gives us 145.2828 as our volume of solid S. We know that the paper weight, we know that the paper weight we know that the paper weight is made up of two solids that are joined together. So the volume of the solids would be, so the volume of the paper weight would be 2 into the volume of our solid S. So 2 into volume of our solid S is equal to 145.28 and 28. And this will give us 290.5656. And we have to give our answer to two significant figures. So 295.5656 for two significant figures will be equal to 290. 290 unit cubed. We know from the question that the height of the paper weight is 8 centimeter cube, is 8 centimeter high. So the height of the paper weight is 8 centimeter. So the height of our volume S would be 4. As our height of the volume S is 4, we can see that from this area the 4 centimeter height is represented by this 4 unit line. So we can say that 4 centimeter in our object is equivalent to 4 unit from our graph. So this means that a volume of 290 unit cube will be equal to 290 centimeter cubed in real units. So this is our answer to our part C. And this concludes our question number 9. This concludes our question number 9. We can see that we have to use proof by contradiction to show that for all angles x, where x is within this range greater than 90 degree but less than 180 degree, our expression cos 2x divided by cos x minus sin x is less than 1. We have to show that. We have to show that this expression will be less than 1 for all the values of x in this range. So at first we will assume the opposite. We need to prove that for all angles our expression is less than 0. So we will assume the opposite. We need to assume that there exists an x. There exists a x for which our expression with modulus is greater than or equal to 1. We need to show this. We are assuming this. We are assuming that there exists a value of x in our range 90, x is greater than 90 but less than 180. We are assuming that there exists an x value within this range that will make our expression greater than or equal to 1. We can simplify our equation. So I know that cos 2x is equal to cos square x minus sin square x. We know this from an identity of cos 2x. So I can write, instead of cos 2x, I can write cos square x minus sin square x divided by cos x minus sin x and modulus. And we have to give the modulus. And this is greater than or equal to 1. Now, in the numerator we have cos square x minus sin square x. We can write write it down in terms of factors using the a square minus b square formula. So this will be equal to cos x plus sin x into cos x minus sin x divided by cos x minus sin x with modulus is greater than or equal to 1. From here we can see that we can cancel out cos x minus sin x. Now we see that cos x plus sin x is greater than or equal to 1. We can square both sides. This will give us cos x plus sin x whole square is greater than 1 square, which is 1. We can expand the brackets. This will give us cos square x. We are expanding this using the a plus b whole square formula. So this will give us cos square plus 2 cos x sin x plus sine square x is greater than equal to 1, or we can write, or we can see that we know the identity that cos square x plus sin square x is equal to 1. So we can, from this expression, we can add cos square x and sin square x, and together we can write this as 1 plus 2 cos x sin x is greater than or equal to 1. We know from another identity that sine 2x is equal to 2 sin x cos x. So we can write 2 cos x sin x as 1 plus sine 2x. We can move our constant term 1 to the right side, and this will give us sine 2x is greater than or equal to minus 1. So this will give us greater than or equal to 1 minus 1, which is 0. So what this equation tells us is that for every single values of x within the range, the value of sine 2x will be greater than 0. We know the range for our x is greater than 90 or less than 180. If we adjust the range for 2x, we get x is greater than 2x is greater than 180 but less than 360. From this we can see that if 2x exists within this range, 2x exists, this is 0 and this is 90 and this is 180 and this is 360. Our value for our angle 2x exists in these quadrants. We know that in the third and the fourth quadrant, sine 2x is less than 0, is negative. But from our equation, we see that we have a contradiction here. Our equation shows that for sine 2x, the value of sine will be greater than 0. And this cannot occur. That's why there is a contradiction. So we can write there is a contradiction. Hence, there hence we can write for all values of x, our expression is greater than 0. Is greater than equal to 0. Is less than 0. Is less than 0. So we have proved the statement in our question. At first we have assumed the opposite and then we tried to prove the opposite statement true, but we found a contradiction, and as we found a contradiction, we can say that the statement in the question is true. So this concludes our question number 10, and question number 10 is the last question for this paper. So thanks for watching, everyone. Consider subscribing our channel because we keep bringing these videos constantly out. Thanks.